Hello, good morning, sir.
Yeah, very good morning to you all.
Good morning. So, can we start, sir?
Yeah, sure.
Okay. So, dear participants, good morning to all. So, today is 17th of March, and the first session in this 1 week FTP, we have with us Dr. Arjit Roy. So, Dr. Arjit Roy, he is presently working as assistant professor at Indian Institute of Information Technology, CIT. Prior to joining this institution, he worked as a postdoctoral research fellow at the University of Luxembourg. Dr. Rai completed his PhD and MS from the Smart Wireless Applications and Networking Lab, Indian Institute of Technology, Kharagpur. He works in the domain of Internet of Things and sensor cloud. His research works were published in several reputed journals and conferences, including IEEE, ACM, Transactions, etc. He has also filed various patents, and patents were also granted. He's an author of a book on Introduction to Internet of Things, published by Cambridge University Press. Dr. Rai was recognized with several awards such as IEEE TSCS Outstanding PhD Dissertation Award, Samsung Innovation Award, IEEE ComSoc Student Competition Award, GYTI Award, and many other prestigious awards. He also received a few prestigious fellowships during his PhD, such as the Indian France Raman Charpak Fellowship and the Council of Scientific and Industrial Research Senior Research Fellowship. Dr. Rai served as a mirror committee member of Luxembourg, ISO, IEC, JTC 1, SC 41, IoT and Digital Twin. He is also a member of IEEE and ACM and very active in different international IEEE activities. Dr. Rai is also co-founder and director of Sensor Drops Networks Private Limited. So I welcome you, sir, in this 1 week FDP. And sir will talk on the Internet of Things with machine learning. So now I request Dr. Arjit Roy to start with his presentation, sir.
Yeah, thank you. Thank you, Dr. Saurabh, for your nice introduction. And let me share my screen first. Okay. My screen is visible, right?
Yeah, sir, it's visible.
Okay. So once again, good morning to you all. Right. So as Dr. Sastri already introduced me, let me discuss about myself from my side. So I'm Dr. Arjit Roy. So I am currently working as an assistant professor at IIIT Sri City, which is located at IIIT. This IIIT is located at Sri City, which is you can say the hub of multiple manufacturing companies. So we have around in this area we have around 200 companies, and those are very big companies, including Cadbury, Cobelco, then Colgate. All these all other manufacturing companies are there, and that is the location of our institute. So and I work in the domain of IoT and sensor cloud. That again I will discuss in very brief. But before going into that, let me discuss about today's talk. Today's talk is on machine learning for Internet of Things. So in this talk, I am not making it very much complicated. I am not going into the very advanced level of machine learning thing. Only basic thing I will cover, because whenever we are talking about IoT or ML in IoT, then we have to understand all the generic or general algorithm may not be useful. Before going into those complex algorithm for IoT, we should know the basics of this machine learning. That's why I plan to cover this thing. And as it is an like traditional FDP, so I thought of giving you some knowledge about this basic machine learning, right? So these are very trivial thing, I know, but still I want to cover this portion, because if you will understand this basic, then only you can dig into the IoT part. For IoT, there are different energy constant, or you can say the resource constant machine learning algorithm that I am not discussing today, but the traditional machine learning algorithms, I will discuss a few. And this presentation will be based on my book, that is Introduction to IoT. And along with me, after my session, I invited my PhD student also, Mr. Ramakrishna Rath. So he will be giving you a basic idea of implementation of this machine learning, but in very brief, I will discuss. We can drag it into a long time, but due to interest of time, it may not be possible to extend it. But before going into the talk, so this is the overview of my talk. First, I will discuss about the ML and how it is related to IoT, all these things. Then advantages of ML, challenges in ML, types of ML, then selected ML algorithm I will be discussing. After that, the performance matrix. All these things, whenever we use it in different forms, right? And nowadays, the different tools are available from where you can directly import this ML algorithm, right? So before importing, we should know the basics. We should know the background story, how it is working, how an ML algorithm is working, right? So for that knowledge, I tried to give you include those things in these slides. Okay. So my research area is broadly in Internet of Things. So I worked in the domain of sensor cloud, then UAV networks, then camera networks, software-defined networks, and wireless sensor network, which we consider as the subdomain of IoT. So I worked on that, and currently also I am working. Particularly, I am focusing on the UAV network. Specifically, you can say UAV as a service. That is a very new and unique service platform, we can say. On that I am working. And the application wise, or you can say the application specific implementation of this IoT, I worked in the domain of healthcare, agricultural system, transportation system, industry, and society 5.0. This is my startup. In my startup, as you can see, it is the name of the startup is Sensor Drops Networks Private Limited. And this startup, in this startup, we are three founder and directors are there. From left in this figure, you can see the leftmost side. This is Dr. Anandarup Mukherjee. He's in Cambridge University currently, working as a research assistant. Then Professor Sudhir Misra, I think many of you are aware of him. He's a professor at CSC department at IIT Kharagpur. Then at right side, I am there. So we work in the different verticals, including including healthcare, agricultural system, and industrial system. So agricultural system we recently started. Along with that, we are working towards the home automation system also. So if you are interested to discuss about the product or the systems of our startup, you are welcome. You can connect me. You can at the end of this presentation also, if you want, you can connect. So we sometimes work collaboratively also, and we are really searching someone who can take our product to the market. Now, let us start with Internet of Things. As we know, this Internet of Things, it is a holistic approach. Holistic in the sense that it has different enablers. Enablers in the sense from the hardware perspective or from the support perspective, right? So from the hardware perspective, we can say the sensors, then different network components, then fog devices, cloud devices, or we can say these actuators. All these things are coming. Okay. Now the sensor, it sends some data from its environment, but after that, what it will do? It has to transfer those data, transmit those data to a centralized unit for further processing, right? So for that, this sensor transmit the data through networks to the fog or cloud, and based on the requirement, this fog device or cloud device, or let us say not cloud device, it is better to say cloud. Essentially, it is device only, that like combinations of multiple device, those are virtually connected. So we can say that device, but the point is, when the application is very time critical, then we can go with fog computing. Otherwise, we can go with the cloud computing. Okay. So based on the requirement, and after the analysis of those data, we have to take some action. That can be an actuator, that can be an action, right? So based on your very simple, very small example I am giving, based on the temperature of your room and the temperature outside and the availability of a person inside the room, your fan or AC is switched on automatically using some IoT based home automation system, right? So actuation is here, switching on the fan or AC. Correct. So these are the hardware components. These are we can see physically some components, right? But these components are not enough to get some IoT based services. For that, we need some supportive technologies, which are artificial intelligence and machine learning, then containerization, virtualization, and security. These are basically, most of them are concept or the technologies, right? So ML is very much important. For that, we'll discuss ML basics in this lecture. Okay, then we can, based on those lecture, we can go to the complicated this ML algorithm for IoT. Then containerization, that is very much important for providing the service to the end user. That is very important nowadays. Then virtualization. Virtualization is it is nothing but, if you most of you, I think you know the concept of memory virtualization. It is similar concept. There is one particular device or something, some component is there, and that is shared among multiple users or multiple applications. But that particular user is thinking that entire device or that particular component is specifically delivered his service, his or her services, right? But actually it is not. It is serving some multiple applications. So that concept is virtualization. Virtualization is also important due to requirement of the efficient utilization of the resources. Now the security. Whenever we are talking about IoT, it is a holistic approach. So multiple actors are involved in any of the IoT platform. It can be user, it can be some service providers. So security, the breach of security is it is very common in any IoT platform. So security is another aspect that we need to consider whenever we are talking about end-to-end IoT system. However, these are the this figure is a overall idea of IoT, but here we will focus on the machine learning, right? So let us go to this. As I mentioned, this is my book. You can go through it. It is based on different IoT related technologies, and I covered all the essential aspects of IoT in this book, and it is not so costly. It is available in Amazon. So based on this book, I prepared these slides. So I will discuss the different machine learning approaches considering this content of this book. So term machine learning, I am starting it very at the beginning. Also, I told that I will be covering from very basic and the background of the machine learning. So machine learning term is coined by the American scientist Arthur Lee Samuel, right? So he was a very popular scientist at that time, and particularly after coining this term in 1959. Now, see, nowadays we are getting different type of ML technique, ML algorithm, right? But the concept, basic concept, is given at that time, and now it is evolving also, right? ML algorithm, we are trying to find out different, we are trying to design different type of ML algorithm in order to cope up with the current advanced scenarios, advanced applications. Now, machine learning, this term is very simple. Like a machine is nothing but the computer, okay, or the computing devices. These devices are learning by itself based on the experiences, based on the situation, based on the prior experience, based on the current experience, and so on. So you can say, as if you focus in the second point, it is written that field of study that gives computers the ability to learn without being explicitly programmed. So that means we are not based on the situation, we are not programming it, and we are not asking for some service based on the situation. Rather, the computer or the computing device, it is learning by itself to serve certain applications, right? So it's very powerful tool, as as I mentioned, that it can learn from the past experience and current experience, and at the same time it is changing, it is updating, it is improving its performance, right? Now, in IoT, different intelligent systems, whenever we are talking about IoT, we generally consider the systems are intelligent, such as your transportation system, such as your healthcare, then industrial application. All these things, these are nowadays we call it as intelligent system, right? So providing those intelligence in those system, we need the support of ML. Okay. For example, very simple example, like I want to predict some disease of a patient in healthcare IoT, right? So I have to be dependent on ML. Or in industry, let us say there is a big equipment and it's very costly and it is very essential. How can I predict the downtime of that particular device? For that also, we can use this ML algorithm. So this ML algorithm, it is machine learning. For learning, we need the support of our basic science, or you can say the combinations of basic science and advanced science. Okay. So those components are statistics, mathematics, and computer science. Because it is very computation this intensive. Okay. We may not, whenever we are using ML algorithm, it is easy. You are getting some algorithm, you are implementing it, it is very easy. But building that ML algorithm, any new algorithm you are building, that is challenging. It should have strong mathematical background, or statistical background rather, right? Along with the knowledge of computer science. Then only some machine learning algorithm can be developed. Now, these are the advantages of ML, that is self-learner, time efficient, self-guided, minimum human intervention, diverse data, diverse applications. So in this lecture, I in a very compact way, I tried to focus on the step by step what are the requirement for understanding the ML. So this is one of them, that is the advantages. So self-learner, as I mentioned, that based on the experience, it can learn. The system can learn, right? So for that, it can be, this experience can be prior experience, it can be the current experience. Based on that, I am predicting the future, right? So as an example here, it is written like ML assisted weather monitoring system. Okay, I am predicting the weather for the next 7 days. So I have a few data. So based on those data, I can predict the future weather, right? I have weather data for the, let us say, last 8 months or 9 months, like that. So I can predict the future. Okay, the system offers even better accuracy when it analyzes the weather data that extended back to 3 more months. That means it can, if we let us say earlier we are considering 9 months, so it can be 12 months also. So it is ML is dependent on the this data, right? For that, the this amount of data, if the amount of data is high, or the I have the more amount of data, then I can give a better result. That is there in the ML. Okay, then time efficient. Time efficient, so same thing, same example. If it is manual calculation of manually also you can do, right? It will take some time. You can do some statistical analysis. You are writing page after page. You are like calculating something. You using different mathematical approaches. You are using this, and you are giving the result. You are predicting the weather, right? But it is time consuming. On the other hand, as the computer science is involved in ML, so it is time efficient. Self-guided. Okay, so focus on this point, that is uses a huge amount of data for producing its result, right? So huge amount of data is required, and as the data amount of data is high, it can be guided by itself, because it has knowledge of everything, all the possible data, right? So it is capable of analyzing those huge amount of data for identifying the trends this autonomously, right? Now, as an example, when we search for a particular item on an online e-commerce website, an ML tool analyze our let us say our search trend, and based on our search trend, it is next time whenever you are browsing it, it may show the similar sort of items. Then minimum human intervention or interaction is required, that this is it is related to the previous advantages like self-guided. Okay, so the human, you are not giving manually every time data to update. You are giving some data set, it is getting trained, and it is giving the output based on at the future based on the requirement, right? So minimum human intervention is required. So diverse data handling. Okay, now one of the challenge whenever we will go for the manual thing, you see this data may not be of similar type, right? Data can be anything. If I am taking an interview of a participant, so if the answer of the question is yes or no, that is also a data. The educational qualification and its marks and all, that is also data. So data can be diverse, right? So IoT system consists of different sensor and produce diverse and multi-dimensional data. That is, now it is very important for IoT. Whenever we are talking about IoT, multiple heterogeneous sensors work. Those heterogeneous sensors produce different or diverse type of data and diverse amount of data, right? So that can easily be handled by some ML algorithm. As an example, consider the profit of an industry in a financial year. So profit in such industry depend on the attendance of the laborers, consumption of raw materials, and performance of heavy machineries. Considering all, so these three parameters that we are using, those are different, those are diverse. The attendance of the labor is associated with the RFID data. On the other hand, the industrial sensor help the detection of the failure of the machinery. Okay, and scanner helps the tracking the consumption of the raw material. All the different sensors we are using in some industrial IoT applications. So for that, it is very but the ML algorithm that can handle this diverse type of data. Then diverse application, right? So applications are also diverse. whenever we are talking about IoT application, it can be healthcare IoT, industrial IoT, then a smart home application, and many others, agriculture. So all can be this. If you have a particular ML algorithm, the same algorithm can be used for different applications. But you have to remember that the data or type of data that is different, or the amount of data also, right? So these are few advantages in ML. Now there are few challenges also. Okay, these challenges are listed. It is the traditional challenges, but here I would mention, whenever we are talking about IoT or IoT applications, the challenges, you can say that it increased twice at least. Because whenever we are talking about IoT, it's a holistic approach, right? So multiple types of sensor, actuator, devices, your actors, they are involved. So for that, the dynamicity also it increased, and at the same time you have to get the result almost in real time. Okay, so this let us discuss about the traditional challenges first, like data description. So if you are gathering data, that is not enough. The data should be meaningful. Data should be it should give some information, it should carry some information. So data description is a challenge, how you are defining those data. Second is the amount of data. As I mentioned, that it is ML is heavily data dependent. So the whether your ML tool or ML algorithm, whether it is giving the correct output or not, that is dependent on the amount of data that you have collected. Then erroneous data. The learning of a model is heavily dependent on the quality of data. That is erroneous data, mislead the ML model. It is very obvious. Okay, if I have in my class, if I have a student and I am asking for the feedback for that particular student, and let us say 3% is saying that student is not good, but 7 are saying he's a good. Okay, so based on this data, my impression maybe he's an average student. Okay, but actually he's a good student. So that erroneous data, that error, that can mislead my inference, right? Now, selection of the model. This is another important part. Like model, there are different ML models are there, but which one I have to select for my application? Which one will be appropriate? So selection of an appropriate model is an important thing, and it is a challenge. You have to select it appropriately. And quality of the model. Okay. Now, if you are selecting a model, you have selected a model, but whether it is giving some quality, like this quality, it is giving some proper quality or not, that is important, right? That means it is giving some quality output or not, that is important. Now there are different types of ML we can categorize it. One is supervised, another one is unsupervised, semi-supervised, and reinforcement. So here you can see in many books and all, you may get some changes, minor changes in this. In some books it is directly starting with the classification, regression, clustering, association, like that. So we have categorized it like this, that in supervised learning, classification and regression, then unsupervised learning, clustering and association, and then semi-supervised learning and reinforcement learning. So it is very important to know the actual meaning of the supervised learning, unsupervised, semi-supervised, and reinforcement. This is very basics of this ML. Supervised learning is if we have the level data. Okay, I know if I am seeing a device, I know after seeing a device, oh, if this is a device, it can be a pen. Okay, it is looking like that, it is pen. I'm labeling it. Okay, but unsupervised learning, it is based on the unlabeled data, right? This is no label. Semi-supervised learning, it can be combinations of both, and reinforcement learning, it is based on the experience, of the agent from the environment. Okay. Now in supervised learning, this type of learning supervise or direct a machine to learn certain activities using label data, as I mentioned in the figure, right? So that label is very much important in order to use as a supervisor of the model. Okay, and see, it is giving some training to the machine that you should react like this. So this supervisor, this label data, right, this is helping in understanding the machine, the relation of the label that we are using with the property of the corresponding input data. Some properties are there, right? So supervised ML algorithm are very popular in solving this classification and regression related problem. The classification deals with the predictive model that are capable of approximating a mapping function from input data to categorical output, right? You are classifying it, you are categorically, you are dividing it, right? Or you can say you are classifying the particular data. Okay. So, but the regression, it provides the mapping function from the input data to the numerical output. So both are important, and unless you are applying some machine learning algorithm for some application considering some data set, it will be not much clear, but the theory behind this supervised learning is this, and there are two parts, as I mentioned, this classification and regression. Now let us see what is regression. In very brief, I will be covering this regression. Many of you, I am sure that you know. So regression is you should focus on this formula. Okay, y equal to beta 0 x0 plus beta 0 x0 beta 0 x0, like that. So this beta 0 x0, this 0 can be, sorry, it should be beta 1 x1, it should be beta 2 x2, right? So all this beta and x, okay, this has some impact on y, right? So the dependent variable are the primary factor that we want to predict. Okay, in this figure you can see that y, it is dependent on the beta 1, beta 2, beta n, that can be n number of betas. These dependent variable are affected by the independent variable. These variable are independent, x1, x2 and x3. Okay, there is no dependency for them, but y is dependent on them. And beta 1, beta 2, beta n, those are the impact, you can say the weight. Okay, so based on the previous figure, that is beta 0 x0 plus beta x, let us say for simplicity, and plus some epsilon was also there if you see in the figure, right? So beta represents the amount of impact of variable x on y, and it denotes an error. So in the given equation, you can see this, if we consider this particular part, this beta 0 and x0, so x0 is creating beta 0 impact on y. Clear? Once again, this x0 is creating an impact of beta 0 on y. Correct? Now, the value of y, it cannot be 0 because it has always some impact, right? So when we consider, this is a simplified way it is mentioned, but if with some generalization, you can say for multiple variables, say n, like if there are n number of x are there, so in a generalized formula, we can write it like this. And here epsilon is the error. Now unsupervised learning. Unsupervised learning algorithm use unlabeled data set. Again, this thing also I discussed in the in the figure. Now, unlike our previous case, that is in supervised learning, in unsupervised learning, it like category that try to identify nature and the property of the input equation and the nature of the formula responsible for solving it. Okay, there is some difference between, if you go back to the supervised learning and here, you will find some difference, right? So it will be more clear when we will give some example of unsupervised learning. So unsupervised learning algorithm try to create different cluster based on the features of the formula. That means clustering, if we say, that comes under the unsupervised learning. Unsupervised learning is usually applied to solve two types of problem. One is clustering and association. Now, after that, the semi-supervised learning. So semi-supervised learning belongs to a category between the supervised and unsupervised. Here we use the labeled data as well as unlabeled data. Okay. So see, practically this labeled data is expensive, right? Expensive in the sense that it may have more like description sort of thing. You need to have like it is expensive in different forms, right? But and you may not use all this labeled data every time. So in a smarter approach is to use some semi-supervised learning considering the unlabeled and this labeled data. Okay. So semi-supervised learning includes both labeled and unlabeled data set to design the learning model. The semi-supervised learning uses mostly unlabeled data, which makes it efficient to use and capable of overcoming sample with the missing labels. Reinforcement learning, here the agent is coming into the picture. So reinforcement learning establishes a pattern with the help of its experiences by interacting with the environment. That means it is a system, a machine, it is learning based on the data or the situation that we have in our surrounding, in the environment. So for that, agent is performing a role, okay, to get this reinforcement learning model done, or to develop this one. Okay. So it aims to achieve a particular goal in an uncertain environment. The model starts with the initial state of a problem for which different solutions are available. See, for a baby, how something we are trying to teach them, A, B, C, D, that, but something they cope up, they understand from the environment, and he or she learn, right? After certain amount of time. So that learning is that we are not feeding. We are not saying that this is a paper, this is pen, this is copy. It's not like that. We are not saying. But from the environment, they are getting some knowledge, they are gathering some knowledge, and based on that, they are developing their learning expertise in that, in themselves, right? Now in classification, we will cover very basic algorithms over here. And as I mentioned, that using this algorithm is easy. You can get many tools to get this algorithm. Directly you can get, but I'll be providing to give you some basics of this all these algorithms, whatever I will be discussing. So this is KNN, that is K nearest neighbor. KNN learning falls under supervised learning. Okay. It also known as lazy or instance-based learning. Okay. KNN learning is one of the simplest algorithm as it needs to explicit training model. This selection of a suitable K is essential to split the dataset into K cluster. Here we are talking about the classification, right? So K plays an important role to classify the data based on the value of the K. So it is very difficult to determine the value of K. For that, you have to It is obviously it is dependent on the applications, what applications for what applications you are using it. It is dependent on that. But again, after having so many of constants, so many of like dynamic situation, it is very difficult to determine the value of k. Now advantages. In KNN, it is easily implementable because it is very straightforward and very simple. When I will go through the step, you will understand. Easy handling of missing data, does not learn during the period of training, therefore is faster compared to the other ML algorithm. Then in disadvantage, it is noise sensitive. It needs a large memory space because training is involved. So for training also you need data. Okay, for testing also. So it may take large amount of memory space, and it does not work well for a large and high dimensional data set. So how you will perform this KNN? That is, select a value of k where k indicates the number of nearest sample point necessary for the applications. Nearest sample point. Compute the distance between the given data point to all the available training data points. I'm coming in some with some example. It will be more clear. Sort the distance in ascending order. Consider the kth nearest distance and identify the corresponding class of data points. It's identify the majority of the class of those k nearest neighbor data points as the class of unknown data points. So this is very crisp, very like organized way it is written is all these steps, and whenever this KNN algorithm is implemented, all these steps followed, right? Now selection of a k, that is important. I mentioned this thing. So k indicate the number of nearest neighbor necessary for predicting the output in a particular model. An appropriate selection of k is crucial to avoid anomaly. Because if you are changing, if you are keeping some higher value and lower value, so it may change. It may if you are keeping extremely small value of k, it may variance of this data point may be very high, right? On the other hand, if you keep the value of k is very high, so at that time also there may be some biasness in the output. Okay, and for distance calculation, like as I mentioned in this step, right? This it computes the distance between the data points to all the available training data points, right? So for that, there are multiple techniques based on the requirement. We can use this thing. It is Euclidean distance, Manhattan distance, and this Minkowski distance formula we can use. These are the basic formulas where A and B are the two. It indicates the coordinate, right? Coordinate of the of some data. So using these formulas, you can use this formula to calculate the distance. Now, as an example, in this figure, if you observe, there are two shapes. One is square, another one is circle, and another one is there, that is the pentagon. So the square, it is of class M, let us say, and circle is class N. There are two classes. And this pentagon thing, it is unknown. Okay, this question mark, this pentagon, this is unknown to me. Okay. Now, in this example, if we are taking this k equal to 3, that means 3 nearest neighbor of this question mark are D1, then D4 and D3. And among those 3, we are seeing this, it is of class, like 2 of them are of class M. So we are saying, or we are concluding as this question mark or this unknown data point, it is in class M. Correct? So similarly, if we consider the k equal to 5, so we can say again this D1, D2 and D3 in this 5, when k equal to 5, these are the square and it belongs to class M again. Okay. Now decision tree. This is another method, another approach. Decision tree is a very simple, only based on certain property you are determining that in which way you should go. It is very similar to you can say the data structure of your binary tree, right? So decision tree is a simple and powerful tool in ML that uses the tree for determining its course of action. A tree may contain one or more branches where each of these branches cater to a specific decision. That means based on some decision, it will decide that whether I should go to the left branch or right branch, right? So it consists of two types of nodes. One is decision, another one is leaf node. Leaf node is the essential, I mean, it is the last node, okay? That gives you the ultimate result. So advantage of this decision tree, it is easy to visualize. Data preparation can be done with less effort. It can be used for both numerical as well as categorical data. And disadvantage may be few are like it can do some overfitting if the data contain noise. The proper selection of attribute of data is very essential. Then small variations in data may affect the stability of the model. For decision tree, what we do, it is very simple approach. List all the possible decisions to be made for a given problem based on the attribute. You have to know the what can be the possible decisions. That's why the name is called, it is decision tree. And then determine all the possible events that may occur after making the decision. You are taking some decision, then what can be the sub branches, what can be the like different decision, different possible event that can be done after taking that particular decision. Then expand the tree, that you have to repeat the step 1 and step 2 until you are reaching to a leaf node. For this example, let us say few vegetables are there like broccoli, beans, tomato, then red chili, eggplants, and beetroots, right? Now, if you are taking one of the vegetable and you are considering the color is green, yes, then it can be beans, it can be broccoli, both of them are green. If it is no, then color is red. I'll check. Okay, yes, color is red, then it can be tomato, it can be red chili. If it is not, or again, if it is not, we are checking the length or the diameter at the red side. You see color equal to red, then red can be your, what it is, tomato can be red chili can be red, right? So you are determining at that point the diameter of the particular vegetable. If it is more than 0.5 centimeter, then we are categorizing these as tomato, otherwise we are keeping it as chili. Okay, similarly for length also we are showing it. If it is more than 3 centimeter, we are calling it as eggplant and beetroot, and otherwise it is beetroot. Okay, so this decision we are based on this decision we are approaching towards the leaf, where we are actually getting the classified data. Random forest is again a simple approach. It is, you can say, the combinations of multiple decision tree. That means considering multiple properties, you are preparing one decision tree, then another one, then combining all those things, you are classifying the data, right? Here, the advantages of this random forest is that it can be used for both classification and regression as the based on the decision tree. It provides better accuracy than the decision tree in the presence of large data set. But in disadvantage, it may increase the complexity because it is very simple. Whenever we are making one tree, the complexity, it may be dependent on the creation of that tree. If you are using multiple numbers of tree, your complexity will automatically, it will be increased, right? And this interpretation is difficult due to the presence of multiple decision tree. You have to consider all the decision trees that you are creating, then you have to take some decision. So it is a bit complex. The step of decision tree, the random forest algorithm follows the similar step as the decision tree. Same thing you are doing, only you are combining. If you will go through the example, see, So the same example we are taking where we consider the sample vegetable classification, right? You are doing the same thing. Here you can see based on the color you are getting some result at the leaf node. And here based on the diameter, based on the size, you are getting some data. That means two independent tree you are making. Based on that you are getting the result and you are combining the result to get the final answer. Okay, that is the random. Now coming to the clustering. Clustering is equally important as the classification. So K means clustering is an unsupervised ML algorithm used for clustering. Here also, unlike our KNN, here K is indicating the number of distinct cluster. So this algorithm follows an iterative process for dividing the data set into K distinct cluster. K means clustering uses the Euclidean distance between a point and the cluster's centroid for the its operation. These things will be clear again with some example. These are the advantages. This compact cluster as compared to that in the hierarchical clustering provide a faster computation with a small value of K. Now in disadvantages, initial selection of the random point may affect the final result. Difficult to decide the value of K. Very similar to like KNN. Now these are the basic steps that are followed for typically K-means algorithm. It selects a value of K to determine the possible number of cluster first, then randomly choose a value of K as the distinct number of data points and consider those as the centroid of each cluster. It takes any data point and measure its distance to the centroid of all the clusters, where a centroid is the center location of the cluster. This step, you just remember, try to understand this step. We'll see some example. First step is select the value of K. Okay, because I have to know the this distinct cluster that I want to form. Then we are selecting some value of K. Okay, now we are taking any data point K and measure the distance with the centroid of all the cluster. And K means algorithm associated the data point to the nearest cluster. And we are repeating this step until we are getting the repetition in the cluster. That means the centroid, same centroid unless we are repeating this step. Example, let us consider a data set consisting of 3 types of data as depicted in figure here. Okay, so here K equal to 3, so we know that there will be 3 cluster. In the this let us say C1 is the one cluster, C2 is another cluster, C3 is another cluster. So in this circular shape C1, this is the data, this is the data, and we are finding out the centroid every time. Okay, so when we are considering this, we are getting this C1 as the centroid. Okay, and when we are reiterating it, we are getting the another cluster. That means at this time we are seeing that this data, it is included in this cluster in C1. Similarly, here the unknown data, that is this C3, it is coming into this cluster. Again we are repeating the step. We are getting the different result, that is these data are here, but here you can see this and this, like in the second figure, this data is coming over here at C2. Okay, now we are repeating the steps again and we are finding that there is no change, so we'll stop our algorithm. Okay, now another one is the agglomerative clustering. This is also very popular, but you have to you have to concentrate only on this. There are different mathematical part, but anyways, as I am saying multiple times, all these algorithms, those are very readily available nowadays. So agglomerative clustering falls under the category of the hierarchical clustering algorithm. This is hierarchical clustering algorithm. We'll see how it is forming this hierarchy. This clustering algorithm uses a bottom-up approach in the form of tree as the name suggests, it merges similar cluster to form a bigger ones and finally stop at the forming a single cluster. That means we are taking, let us say, with two, then we are making it, we are combining it if it is possible, then we are considering with this two, another one we are considering. So finally we are getting it to the single hierarchy. Okay. So as the name suggests, it merges similar cluster to form bigger ones and finally stop by forming a single cluster. Agglomerative clustering algorithm are three types, which are as follows: single linkage, complete linkage, average linkage. Consider the minimum distance between any two data points from two different clusters. Complete linkage, that is, considers the farthest distance between any two data points from two different clusters. Then average linkage, that considers the average distance among all pairs of data points. For simplicity, we'll discuss only with the single linkage over here. So advantages and disadvantages of this agglomerative clustering is that in advantage, all the advantages of hierarchical clustering, simple dendrograms provide what is dendrogram, that also I will see, provide the sufficient information about the cluster, simple and easy to implement. In disadvantage, all the disadvantages of the traditional hierarchical clustering. And most important disadvantage is that if a data point is assigned to a cluster in the initial phase, it is difficult to assign the data point in other cluster in the later phase. It will be clear when you go through the example. So these are steps it's pretty simple. Like steps for agglomerative clustering is each of the data point is an individual cluster considering all the points from the distance matrix by computing the distance among them. Merge to closest cluster based on the existing distance matrix and update accordingly. Continue step 3 until we form a single cluster. So now you go through it. I'm going to the figure. Only you simply think that there are few data points. For here we are considering 5 data points: P1, P2, P3, P4, and P5. X and Y are the coordinate of this. Each of these point, they have their coordinate. And if we have coordinate, we can measure the distance also, right? And based on that distance, we are grouping it. We are forming the dendrogram. Let us see how. See, P1, P2, P3, P4. For this, in this table, you can see the X and Y value is there. That means X-axis, X coordinate and Y coordinate is there for each of this data, right? Each of this data point. Now I am comparing. I will compare with all the data with all other data. Like P1 we are considering with P2, P3, P4, and P5. Then similar thing we are doing. So here we see we are forming this comparison table. Okay. In this table, we observe that P2 and P5, this distance is very close. That is the smallest one. So we will merge P2 and P5. And we are considering this P2 and P5 is as a single data point. So that is a disadvantage. If we are merging this P2 and P5 at later instant of time, we cannot merge P5 with P3 or P4, or we cannot merge P2 with P3, P4, P1 like that. So that's why there is a disadvantage. It is mentioned that if a data point is assigned to the cluster in an initial phase, it is difficult to assign the data point in other cluster in the later phase. Okay. So similarly, we are seeing that P2 and P5, it is nearest to P4. So we are including P4 also. Then P2, P5, P4, it is becoming a this single cluster. Similarly, now we can find that P1 is closest to P2, P5, and P4. We are merging this, and in this way we are completing it, and we are finding the final dendrogram. DB scan. DB scan is the density-based spatial clustering of applications with noise. Okay, that is DB scan. It is very popular algorithm, but it is a bit complex, I would say. So DB scan is a clustering algorithm that works based on the density of the data point. Okay, how much it is dense. Whenever you have data, you have its coordinate. So how much it is dense, based on that, it will work. So this clustering algorithm belongs to the category of the unsupervised learning. Typically, DBScan focuses on the data points that are close to the given data point and generate a cluster based on the density of the region. So DBScan consists of two crucial components. One is epsilon and another one is the minimum points. Okay. Again, this epsilon and minimum points we'll see. Epsilon is typically represented by the EPS and epsilon symbol, which decided the considerable radius of a given data. That means whenever we are specifying this epsilon and epsilon of a particular data, we are considering the radius within which radius we can consider the other data point. Okay. The minimum point is represented as mean point there or mean PTS, which represents the considerable minimum number of data points in a dense region. So in DBScan, there are three main points. One is core point, another one is border point, another one is outlier or the noise point. So core point, this point consists of the number of the neighbor data points more than or equal to the value of mean points within a specified epsilon. Border point, as its name suggesting, these are the points that directly connect to the core point, but have the number of the neighbor data point less than the mean point. Outlier, the points that are neither core or nor border. Okay, so in DBScan, there are few advantages. Like in the DBScan algorithm, the priori declaration of number of cluster is not required. It can reduce the arbitrary shaped cluster which are robust to handle noise or the outlier. Disadvantages, it is very difficult to choose a suitable value of the epsilon because it will depend on the value of epsilon. We'll see in the figure that the epsilon value we are considering, we are considering that radius to consider the other data points. Okay. This algorithm is unable to produce a cluster efficiently in the presence of the varying density in the data points. So for data points, we try to find the which one is the core point or border point or the outlier. So we assign the value of epsilon and mean points, consider a random data point and check the distance d between the data point and its neighbor. Then count the number of neighbors of a data point that are located at the distance below a predefined value epsilon. Okay, that means the distance, if you are getting the d, then we will check that whether d is less than this thing, epsilon. Okay. If the number of neighbor is more than or equal to the you should point this thing. I mean, you should focus on this thing. If it is more than or equal to the mean point, then we consider that data point as a core point. Okay. So we'll reiterate these steps. Okay. This 2 to 4. Now for a data point, if the number of neighbor is less than mean point and it is directly connected to the core point, then the point is considered as the border point. The core data points and the border data points makes the cluster. Among the data points, the one that do not have any neighbor correspond to the noise that is like which is not belonging to that cluster, that we consider as outlier. Okay, so in example here we take this mean point as 3. Okay, now in this figure, all these are data. Let us take A, this red color point. This is the epsilon, this is the radius. That means within this radius we will consider the data. We have 3 other data. So here we will see the value of this epsilon, this distance of, we are comparing the distance of between this data point with others available one within this epsilon value. If it is less than this epsilon value, then we will consider it will be in this cluster. Okay. And second one, B, another data that is in the figure first, this one. Okay, this one. So again, we are defining that epsilon, and within that we have 2 other points, and we are seeing that this is less than D. So I can again consider. Similarly, this is also we are doing, we are getting it is this d is less than epsilon, but here d, it is a single. In this epsilon there is no other data point, so we consider this data as a outlier. Okay. Now, see, before going to the performance matrix, I would mention that all these things, if you have a this computation capable, well capable machine, then you can execute all this algorithm, because you have to calculate sometime distance and this data only with few data we have given the example. But you think whenever we are talking about IoT, it is more diverse. The data amount of data is huge, and the IoT devices is very less computational power. Typically, it is like that, right? Unless it is a server or big machine or a well-capable machine. So for that, it is very much important to design the resource constraint ML algorithm. And it is, I would mention that it is another domain where the researchers are focusing on that in developing the resource constraint ML algorithm for IoT applications, right? So these are the few performance metrics we can see for measuring the how a particular ML algorithm is performing. So basically, very common algorithms are the simple accuracy, precision, recall, and F beta. Okay. Now, before going into that, we should design the confusion matrix. Okay. And this confusion matrix, whenever we talk about this ML algorithm, this is very important. Okay. That whether it is giving some correct data or not, or correct result or not, based on all the performance metrics that we have discussed, that is dependent on this confusion matrix. Let us say, with an example here, I tried to highlight that let an IoT-based cancer prediction system, right, which uses a certain ML model, any ML model. Let us assume that. So in a hospital, there are 10 patients, okay, who are visiting, right, visiting this, whether they are suffering from the cancer or not. So a group of doctors in the hospital uses ICPS, that is in the IoT-based cancer prediction system. Okay, it is not cyber physical system, cancer prediction system we are talking about. So it is, our system will give output whether the patient has cancer or not. Okay. Now it can give some wrong output, it can give some right output based on the sensor data that we have. And it may happen that this ICPS, it may not give the correct data always, correct result always, right? So for that, this particular thing, this particular example, let us see the confusion matrix. So this is the confusion matrix. Here you can see true positive, false negative, false positive, and true negative. So this true positive, it is the patient, those patient who has cancer, and our system is giving the correct result for the same. Okay. Then false negative, FN, that is the patient has cancer, but our system that is predicting that patient do not have cancer. Now false positive is the patient is not suffering from cancer, but it is saying that you have cancer. True negative, the patient do not have cancer, and the system is saying that the patient do not have cancer, right? So this is the confusion matrix, that is true positive, false positive, and true negative. So in this particular case, this true positive is 2, false negative is 3, false positive is 1, and true negative is 4. So based on that, we will measure different the performance of different model. So very simply, this simple accuracy, the number of sample which are predicted correctly by total number of predicted sample. So in this formula, TP plus TN, TP plus TN F plus FN plus FP. That means we are considering all of this, right? And true positive, true negative. Actually, true positive, actually it worked well, and true negative, it worked well. Again, 2 plus 4, that we are considering. So it is giving the simple accuracy as 0.6. On the other hand, if we consider the precision, in that we will see the precision is defined as the ratio of all the true positive TP to the summation of true positive and false negative outcome of the model. The particular example of ICPS, it is the precision, it can be derived using the formula that is TP by TP plus FP. FP means again this particular precision we are considering the true positive as well as false positive. Okay, and how given true positive and false positive, how true positive is working on that and top of that. In the numerator we are writing this. So that is nothing but the precision. Again, using this we can find that 0.67. Recall similar thing we are doing, but if you see here it is at the denominator it is TP and FP, but here it is TP and FN. Same thing we are doing. That means recall is the defined as the ratio of true positive and the summation of true positive and false negative. That is giving 0.33. Now F beta. This performance matrix is used when the performance of a model is difficult to measure using precision and recall. So F beta is mathematically derived as shown in this formula. It is bit different, you can see. So here we take the beta. Beta is typically known as importance. That importance we are giving to the precision and recall. A greater value of precision provides the greater importance to the precision, and let in this system the value of beta is 0.3. Then we compute the F beta as shown in this formula. So here we are getting 338.92. Now error is another important. Whenever we are talking about this data there or the output of the result, there may be some error, right? So particularly we've discussed this error when we talk about regression. So for regression, different performance metrics exist to measure the error of the data point with the regression line. In model fitting, typically data sets are derived into two parts. One is training data and another is test data. That is very well known. Okay. So test data are hidden during the training phase of the model. That also you know. The consideration of error is very much important. Okay. So error is nothing but it is giving the difference between the observed data and the estimated data. I mean this value. So we'll discuss about few common metrics of regression, that is the SSE, sum of square error, then mean absolute error, then root mean square error and mean square error. So these are very much formula based and very straightforward. If you can find out the mean, all are based on that. So sum of square error, that is SSE. This gives the difference between the actual data point, that is yi here, and the mean of all the data point, that is y bar, and we are squaring it as it is mentioned over here, sum of square error. Then mean absolute error, that is MAE, we use the absolute difference between the actual and the predicted data. Okay, we use the absolute difference. Okay, that's why we are using this mode in the formula. Now root mean square error, we are putting some root symbol here. You can see that is another way of finding out the error. Similar approach we are using, similar mean we are using, but in a different form. Then mean square error. This error is similar to SSE and MAE. However, MSE is derived as the square of the difference between the absolute and predictive value in a model. Mathematically, the MSE is represented as shown in this formula. So these are all about this, my theoretical part. So this is particularly we discussed in a very basic way. I tried to discuss different approaches, but it is also true that it is very difficult to cover in depth all these thing together, because this, ML is a subject, right? So it is very difficult to cover all the topic unless we are not practicing it with different data set. It is very difficult to use this thing. I think someone has some question.
Yes, sir. There are few questions in the chat box.
Yeah.
Some have
So
posted in the YouTube, so that's why I have pasted here. So please address these
yeah.
questions.
Yeah, only good morning, sir. Sir, my question is that where we will use ITS in IoT for detection of the intrusion or attack, because my work is on ITS. Okay. See, Amit Kumar, sir, my question he is asking about the ITS. I mean, where we'll set the ITS in IoT. Yeah, ITS is that is intrusion detection system, right? That is very much important. Again, I will mention that whenever we are talking about this IoT, it has different types of component, different vendors are involved, practically you think, and different actors are there, right? It is a holistic system, it is a big system, it has different dynamic components. So this intrusion is a very common thing. Okay. So this intrusion detection system, it is very essential for IoT. Let us say that you have some IoT system for some industrial applications, and in that it is typically this industrial data, those are confidential. That particular industry may not agree to share the data with others, right? But some intruder is entering into the data for affecting somehow, either it is sharing some data or it is penetrating to see the data, modify something. For that, in that situation, in that sort of industrial IoT situation, you can use this IDS. Okay. So suppose one built an IoT system in hardware and acquires the sensor data to do some analysis, trend prediction. How would that person validate the result, as there are no relevant data set available? Yeah, for that different sensors are available, right? This you are talking about the validating that data set. That is whenever we are talking about ML, this validation is important. So for that, one approach is that whenever we are talking about some IoT based system, some industry grade sensor or some see, typically when we talk about the practical, as I have startup, I have gone through with all these phases, I know. So typically when we design some prototype, at that moment we are using some sensor that is easily available online, right? But whenever we are talking about the real implementation, that we at that time we need some industry grade sensor which are costly, at the same time it is validated already. So those data we can use for the validation purpose. Okay. Now why KNN algorithm is as lazy algorithm? Yeah, KNN is as you know, it is K nearest neighbor. So you have to find out the value of K first, and as you know, it is very basic algorithm, and we have to search a suitable K. Along with that, the performance of this particular algorithm, it is very slow, right? Slow learning, because training is required, then after that you have to execute that. So it is due to the features of the execution of this particular algorithm, it is known as slow algorithm, this lazy algorithm. How we find which classification is best? Okay, that is this Pooja Dhar, she is asking that why which classification is best. Again, I will say that best means you have to consider your particular application, right? Which application you are going to use, that is based on the truly whenever we are talking about IoT system. And this IoT also, there are some subcategories of applications, right? In that you have to find out the as per your requirement, you have to find out the best one. That is, there is no specific answer. You have to one option is the trial and error, right? where is the association rule can be applied on data and is expected outcome like also can be hybrid with our sir when the association rule can be applied on data and is expected outcome like also can be with our algorithm. Yeah, this another question is when is association rule can be applied on data and is expected outcome like also can be hybridized with our algorithm. So I think you are asking that whether we can like combine these two approach or not. If it is like that, we can do it again for make it fine tune, make it towards the, if we want to increase the accuracy not for that particular algorithm but for the entire system, then at that moment we can hybridize it or we can combine those things together. So what is the best turning method that we use to improve the performance of an algorithm? So this performance, if you are saying that performance, these metrics are there, different metrics we use, but whenever we are talking about the, if we really improve the performance, from the very beginning of the talk that I was mentioning, this amount of data, quality of data, that the data that we are getting, whether we are getting it from the correct source, then the if we are using the supervised data, we are leveling it correctly or not. All these things will come in the performance. So Pooja Soni, how are these ML algorithms applicable for different IoT system? How to decide which to apply where? That is very good question actually. That how are these ML algorithm this ML algorithm applicable for different IoT system? Again, this is the this is not known. Again, it is very common question in whenever you are applying any ML algorithm. Why not that one, right? So based on your application, you can predict somehow that which algorithm you want to you can use or it may be used, right? But unless you do not have the idea of what you are ultimately you are getting, you want from that application, what you want actually, how and along with that the system, the importance of the system is what. So that is very required to know before applying any ML algorithm. So based on your requirement, again I will say you can apply in IoT in any of the ML algorithm in the IoT system. Again, this IoT system, this healthcare, let us say healthcare IoT. At that moment, this accuracy of the system is very much required, because like a small mistake can be threatened to a life, right? Similar thing for the transportation system, a small mistake can do some accident or something like that in a road, right? So this thing, it is dependent on the application essentially. Then Pooja Soni, how are these ML applications in different IoT system? I think it is covered. Thank you. What about the applicability of ML in IoT system? Pooja Soni again, what about the applicability of ML in IoT system? That is very huge. The scope of applying ML algorithm is very huge in IoT, because in IoT there are different system, and whenever we are talking about at the very beginning, I have shown you a figure, right? So that figure I mentioned that the enablers of IoT, one of the enablers is ML. Okay, it is not like that we say whenever we are talking about prototype, we are only connecting few sensors with the Arduino board and we are showing the data, showing the result. It is not only like that. Whenever it is, if you are talking about truly IoT system, it should give some output. It should be autonomous. For that, ML algorithm is required. Could you suggest some research problem based on application of ML in IoT? See, this is I can see. I can show you some direction that you can approach, but the specific problem you have to find out. But I am giving you the domain or the direction. It is very common nowadays for with this evolving IoT implementation, IoT technologies. It is very important to have this resource constrained IoT ML algorithm that is designing, right? All these algorithms that I have discussed, that is okay, that is fine. That is very popular. Those are very trivial. Those are very popular. Those are very well performed, we can say, if our system is like good, big, well capable. If we are not thinking about the resource, we have enough resource, then at that moment it will work very fine. But whenever we are talking about a Arduino, let us say as IoT device, can that handle that ML algorithm? Or let us forget about Arduino. Can we, if we'll have some Raspberry Pi also, it is sort of a small computer. So how much data it can handle, how much complex algorithm it can handle. So for that, for IoT, it is very required to develop some resource constraint ML algorithm, development of resource. And people are working. You will find few works also. So that's why I have given you in this talk, I tried to cover the basics of this ML algorithm so that you can twist something at the background to get a new ML algorithm for IoT. Okay. So I think I covered all the questions. So Dr. Sastry, can I go with the with some implementation? It's a very basic and few implementation.
Yes. Sure. Yeah, sure.
So my student already joined, Mr. Ramakrishna. Actually, let me introduce him. He is working in the domain of IoT, but it is healthcare IoT. He is specifically working on fog-enabled EEG systems, right? So EEG is traditionally, it is used independently without this IoT, or we are not seeing so much, but he is trying to designing a system where the fog computing can be used for EEG in order to increase the accuracy or efficiency of the system. And after now he is in the phase of designing the architecture. Almost he has done this, but the next work is his like development of or the implementation of ML algorithm in that. So he's working on that. But however, as I suggested him, he will be showing you a basic demo of basic ML, one or two ML algorithm implementation. Okay. So Ramakrishna, over to you. You can.
Yeah, thank you, Dr. Arijit Roy, and a very good morning to Dr. Sastry and all the participants here. So this is Ramakrishna Ratha. I'm working as a researcher in IIIT Sri City under Dr. Arijit Roy. So previous to this, I was working as an assistant professor. I am having experience of 7 years. So prior to that also, I worked in a ITRA funded project in Central University, Hyderabad for 1 year. So my area of research is in multi-domain, as sir mentioned, like I am working on EEG system, EEG signal processing with fog computing and IoT based. So I would take this opportunity to share my knowledge and based on the basics of machine learning algorithms on 2 datasets. Okay, so without wasting any time, I would like to share my screen and start the presentation here. Just give me 1 minute, please. So I hope my screen is visible now. So I will demonstrate the machine learning algorithms on few data sets on Google Colab platform. Okay, so there are many platforms to code the Python language, but Google Colab is the most popular one and convenience one for all the researchers. So I would also prefer the same Google Colab platform. So there are some basic inherent features associated with Google Colab. That is like we can write and execute, we can save, we can import, the data sets easily from the internet, like a Kaggle or machine learning repository. Then even Google Colab, the best advantage is with it supports free GPU system. That is why we can run heavy machine learning codes and deep learning codes with Python in Google Colab. So to start with Google Colab, we need to type in Google first. Then we should have a Gmail login ID to work with this. It's very simple. So what I'm going to demonstrate is the KNN is the most popular algorithm in machine learning. So I will demonstrate KNN algorithm for classification as well as regression. So both classification and regression belong to the supervised learning technique. So for classification, I will use Irish dataset with the implementation of KNN, and for regression, I will use Boston dataset for KNN same. So with the basic introduction to the Irish dataset, this dataset was developed in and around 1930, after 1930, and this dataset have almost 150 rows, and there are three classes. So there are three classes, that is Setosa, Versicolor, and Virginica. So for each class there are 50 rows in that same. So there are 4 features also associated with this: petal length, and special width and petal width. Now, so for the convenience purpose, I have already implemented the dataset to avoid the errors and other things, noises and everything. So I will start with importing the packages first. So before using machine learning algorithm, the dataset cannot be simply give to a machine learning algorithm for analysis and other things. So first we need to import necessary packages and necessary libraries. After that, this data will be pre-processed. Then we can go for analysis of the data. Then we can go for classification or regression as per our wish. So as the first step, we import here the NumPy is a library, and NumPy we import in our case as a NP. We cannot write all these libraries many times. Instead of that, we can use the macros like NP, PLT, etc. So there are the three basic. There are 2 basic libraries like NumPy and Pandas, as you must be aware of that one. The NumPy is used for creating and playing with metrics and arrays, and scientific computing also for numerical data, arithmetic operation, etc. And Pandas also used for making the data frame for data analysis, better data analysis approach. Similarly, sklearn here is imported for predictive data analysis, and it's very much support to machine learning algorithms. Now, the loading dataset. There are various methods to load the dataset. So in classification, where I'm showing now, I'm showing one way of loading the dataset, because all the popular datasets are already there in the machine learning repository. Even like GitHub, Kaggle, also the datasets are available. That is why directly we can load the dataset by this command, like datasets dot load Iris, because I'm using the Iris dataset here for this classification purpose. So I can directly load by using this command. So the dataset will be loaded. I'm running one by one. So even in next approach, I will show a different method of loading the dataset here. Now coming to the third cell. So after getting the Iris dataset, so this dataset is classified into 2 types. One is what are the features and what are the target values. So what are the features here? As the dataset has 4 features, I've already introduced that one. So all the 4 features are in a single part, and the target, there are 3 classes, that is the target one. So that will be in another part. So to see the dataset, just we can use the command like data and with :10. That meaning is there are 10 rows extracted here. You can find it, and each row is having 4 different columns. Each column represent one feature. Though there are 4 features in the Iris dataset, that's why we get 4 columns in each row. Similarly, we can get 10 rows. So starting is empty because we want to extract the row from the very beginning. If we put his value is suppose 2 or 3 like that, we can put, that means it will start from the second row, third row, in that way. Now coming to the next cell here, the next step is we have to see how many classes or features are there. If we did not see from the beginning, then it is shown here like 0, 1, 2. There are 3 classes. First class is 0, that is Setosa. So 1 is second class, that is Versicolor. And 2 which is mentioned, that is third class, that is Virginica. And as there are 4 features here. So the first feature is sepal length, then sepal width, then petal length and petal width. All are in centimeter. So these are nothing but the features of the flower, and these are converted into text, and we are processing with that. Now the dataset visualization part here is shown. Yeah, it is just taking a few seconds to load. You can see here the Seaborn library is imported as SNS. That means Seaborn library is used to visualize the datasets. For better visualization, even there are other methods like matplotlib also there. So anyone can use anything to visualize the data as per the convenience. So there are few parameters. There is one more thing here. If we put on a function, specific function or specific library somewhere here, it will show like what are the argument, what are the parameters can be passed through this. So based of our requirement, we can pass 1, 2 parameters or all the parameters also. Now here I have taken 2 parameters like style. There are various of styles there, dark grid, white grid, then simple dark, simple white, text, like that. So you can experiment with changing these parameter values, and you can see how the data set can be visualized in a better way. Now color code also there. So now the iris data set is loaded, and that variable name is iris here. Okay, it can be seen in the visualization. See the hue parameter is used to see the spaces here. You can see in my cursor, right side of the visualization, there is called spaces. How many spaces are there? Like there are 3 classes, so 3 spaces are there. That's why we are using the parameters, different parameters. And this palette is used for accessing huge range of colors also. Like it is look like colorful, and you can understand better with in the data set. So now you can see here there are 16 figures here in this. In this data set we have generated. So why 16 figures? There are 4 features. So we are pairing each 2 features in a figure. Like the first feature is we have sepal length. That means with sepal length we are trying to visualize the data set with all 4 features: sepal length with petal width, sepal length with petal length, sepal length with petal width, and sepal length with sepal length. Like that, there are 4 features. So for each feature, 4 figures we can visualize. So total 16 features can be visualized here. And each color defines a single class. So there are 3 different species here mentioned on the right side. That way there are 3 different colors. If suppose dataset has a target value of 5 classes, then we can see in 5 different colors all the classes in a single figure. And except the diagonal figures, all other figures shows how the dataset is distributed. The variance of the dataset, how the mean of the dataset is either it is good or not, like that we can see here. Now, before applying the dataset into machine learning algorithm, we need to split the dataset into 2 parts: training and testing. So why do we require to split the dataset now? Because simply by giving the input a dataset to the machine learning algorithm and getting a result, we cannot verify whether it is working good or it is not working good for others. That is why what we do generally is the dataset, some portion of the dataset, we give input to the machine learning algorithm to train it, so that the machine learning can be best fit and give a good accuracy. So how do we measure the accuracy? With the help of the test data set. That is why the data set is split into training and testing here. So how to split train and test means we have taken 4 different variables here: X train, X test, Y train, Y test. So again, we can see here there are 4 data set is split into 2, but there are 4 parameters, because again after splitting the data set into 2, each part can again be split into 2 different. That is, what are the features, that is one part, and what is the target, that is another part. Similarly, train, there are 2 things. Similarly, test also there are 2 things. So in total there are 4 parameters here. So X train is the feature in the training set, X test is the feature in the testing set, Y train is the target in the train set, Y test is the target in the test set. So you can see here the data, already we have classified the data and classes. Classes means the target one, data means the feature one. Now, in which ratio we are going to split our data set? So there is no such fixed ratio till now. Based on how do we want to implement the learning algorithm and how much data set we have available with us? Based on that, we can split, like the best ratio is told as like 80:20 ratio, 80 for training data and 20 for testing data. So here I have taken like 70 for training data and 30% for testing data. So below that is also a good, but not is convenience and not used by the researchers mostly. That is why the most preferable way is 80:20 or 70:30. If the data set is a very huge amount of data, then we can split it to 90:10 also. But if we minimize the testing data set, then we may come across with not a good accuracy at the end. That is why to better splitting is the good option. Now, coming to the KNN algorithm, as it is already taught by Dr. Arijit Roy, the KNN, what are the steps in KNN and how the KNN algorithm getting calculated with taking the distances like that. So here for our KNN algorithm, what are the parameters I have chosen is the distance parameter chosen is Euclidean distance. Apart from that, other distance also there, but Euclidean is most feasible for KNN. It is chosen. And now you can see the K nearest neighbor classifier is a predefined classifier in the Python, which is extracted from sklearn, sklearn.neighbors. That is a library package. So no need to do lengthy of code to implement step by step in the KNN algorithm, because it is though available for our easiest use. Now, in the KNN nearest near algorithm, if we do not pick the K value, then by default it will treat as a 5. And we have an option to change the K values repeatedly. There may be a question like, how can we choose the K value again? That means by hit and trial method, you can choose, like if you take K is equals to 2, how much accuracy we get? K is equals to 3, how much accuracy you will get? Like that you can test. Now for our purpose, now K value chosen as a 5 here. Now there is a function called fit function. See, if you put the cursor, we can see like definition of fit means diff means it is a function. So it is taking 2 arguments, X and Y, like that. So fit is to train the model. Which is the model? Now in our case, KNN model. So fit is the function to train the KNN model now. So what are the argument passed? X train and Y train. This is the training data sets. Now the work of KNN is to predict by using text set. So how it will predict? Now it will compare the actual value in the data set, and it will compare the predicted value in the data set, and to give the accuracy. Let me run this now. Okay, I have not run the previous one. Just 1 second. Yeah, so you can see here. After dividing the data set, we got in X train there are 105 rows and 4 columns. 4 columns means all the 4 features here, and 45 in the testing set, because we have divided the data set into 70:30 ratio. That is why we got 105 in train, 45 in test. Similarly, 105 in Y train and 45 in Y test. So there is no column, parameter here because only one target column is there. That's why it is not shown here. Though there are 4 feature parameters there, that's why it is only 4 here. Now I'm running the second one. Yeah, it is successfully run. Now you can see we did not get 100% accuracy, and it is very difficult to get 100% accuracy also because our data set is not that much perfect. No data set is such perfect. So we got nearly close to 100 accuracy, that is 97% accuracy we got. Okay. So where is the error now? How can we know where is the error it is happened? So to find out the error, we can use the confusion matrix. So as it is already taught, like how confusion matrix is created. On the row side, we put the actual values, and the column side, we put the predicted values. Now you can see here in the first row, the actual setosa. What are the setosa, versicolor, vernicolor? There are 3 classes. That's why there are 3 rows here. Similarly, same thing will be put in 3 different columns also. Now, total number of actual setosa is 14 here, and our machine learning algorithm, KNN algorithm, able to predict exact accuracy, 100% accuracy for setosa, that is 14 to 14. So there is no error here. Now coming to versicolor, this is the second class. Now in second class there are 11 total number of actual prediction, and actual is 11 and predicted value also 11. So there is no error in the second part also. But coming to the third part, Virginica, so there are total 20 actual values of Virginica, but this KNN predicted like 19 is actual and 1 is misclassification. That means 1 Virginica is predicted as a versicolor. That is the one misclassification here. For that misclassification, we got 97% accuracy. So it is not like every time you run, you will get the same accuracy and you will get the same misclassification. So you can test it by running many different times, and you can get many different misclassification also, and accuracy will also change as per that. So this is the classification method of supervised learning using KNN algorithm and iris dataset. Now moving to Boston dataset here. So you might have known like Boston is a popular city in United States. So this dataset is created in around 1978. So there are 506 rows and 14 different columns in the dataset. What is the role of the dataset is to predict the house price. What are the houses available in the Boston city? These parameters on those houses are taken to predict the price. So again, same process will follow. We have the dataset. We will check the little bit pre-processing of the dataset. Pre-processing itself is a vast. Many things are there involved in the pre-processing. That's why I ignored all the parts of the pre-processing. And then after pre-processing, we can go to data analysis. Then we split into data into training and test. Then we apply layer regression method. So before that, again we will load all the necessary packages. So here NumPy is there, Pandas is there, again Matplotlib is there, then Seaborn is there, sklearn, all are there. So there is no such fixed like these many datasets, these many packages only we will use. So based on your operation, you can import many other datasets also or many other packages also. Now here is another method of loading the dataset here. You can see here in the first one I have shown like directly we can load from the source with this command dataset. It will be loaded from the internet, from the authorized source. But here we can use from the drive. What researchers usually do, if we put all the datasets into local machine, there may be a chance of losing of datasets. That's why that's why what researchers usually prefer to load all the datasets into drive. From drive directly we can access, and drive supports a lot of space to store the dataset permanently. That is why this is the method where we can load the datasets, all the required datasets for our research. We can load into drive. From drive we can import the dataset by using this command drive.mount. So the drive will be mounted here. How can we know the drive will be mounted here? So you can see here I have already run this cell. That is why it is showing. You can see the G drive is already here present. That means under G drive, my drive option is there. If you click the my drive, what are the things in my drive, it will show here all this. From this you can copy the path and directly load here it is. Otherwise, one more option is there. Directly by putting this upload option, you can upload the data set from your local machine, and this copy path you can put it here to execute the data set. But the problem with is this, till the connection is there, the data set will be available. Once you close this one, the data set will not be available again. That is the best way to mount the drive and extract from there. Now it is successfully run. Now I will see the data set, how it looks like. So as I already mentioned, in the Boston data set, there are 506 number of rows. You can see starting from 0, 1, 2, 3, 4, and in between all these are hidden, and up to that it's 505. So 0 to 505 total 506 data set, rows are there in the data set. And in the top of there you can see how many columns are there, like 10 here. After that this is broken to next one, that is 11, 12, 13. So 0 to 13 means total 14 number of columns are here. So by seeing this data set, we cannot identify simply like what is the 0th column, what is the meaning of first column, 1th column, 2nd column, 3rd column, like that. So better to put the appropriate heading of the each column, so that by looking at the headings we can understand like which column indicates for what purpose. So our next task is to organize this data set. Now from the authorized source, I have collected the information about each column, like CRIM, the first column name is CRIM, that indicates the per capita crime rate in the Boston town. Now ZN is the second one. So ZN is the proportion of residential land zone in this some given square feet, something like that. So something in NOx is there, that is nitric oxide concentration is there in that environment. So similarly, there are 14 parameters. Each parameter indicates one different purpose. Now, what I would like to say is the last column, that is price, that is our target column here. That means out of 14 parameters, last price column is our target, and rest of the 13s are our feature. By using those 13 parameters, 13 features, we will predict what could be the price of the particular data point. Okay. So to organize the data, like from unnamed columns to the named columns, so we can use this command, like these are the first, we'll define initialize the headings, column headings, then we'll synchronize the df mean data frame we already used. Why you use data frame means through data frame only we can analyze the data. That's why we convert all this data set into data frame first. So now data frame dot columns is equals to housing columns. That means all column, first column will match with first column name here, second column will match with second column name here, third column will match with third column name here. In that way it will match continuously. Now df.info means it will show the information about the data set. Like you can see here, there are 506 entries, columns, and 0 to 505, and there are total column rows, that one, and total columns are 14 columns. Now it can be seen here, like what are the 14 columns. Already it is initialized now, and each column has 506 rows, same number of rows. That means there is no missing value also. You can see null it is showing, and it is showing also the data type, like it is whether float data type or integer data type, like that. So maximum data type here is float. Now this data set takes 55.5 KB of memory also it is showing additional information. Now you can see the data set, visualize it, and you can better understand, like, so what is the first column? First column is crime rate in the Boston city. Second column is some zone. So in that way all these column names are matched, and you can see the last column is price. This is nothing but our predicted class, that is last one. So I would run the next one. So here it shows, like this is the pre-processing step of data set. Like we can get information about whether we have any missing values in the data set or not, like that. If we have missing values in the data set, we have several methods to find it out. So first one is we can directly simply ignore the missing values. What are the missing rows or missing values in the row there? We can simply delete the rows, but that is not the good way of importing that. Utilizing the data set. Second one, you can fill it with some values like average or mean or something like that. We can fill the data set, and some other methods are also there. So though we don't have any missing values in our data set, so we do not need to pre-process with this filling data set. Now coming to the dataset description, again it is clearly describing like count. Count is the number of rows in each column. So the first column 506, again second column 506. It is showing all columns have 506 number of rows. Now mean is there. So mean is a feature. Standard deviation mean, you might have come across these things. Mean like mean means a data point is there, and you have to calculate all the sum of the data points divided with number of data points. We can calculate mean with that. And standard deviation, by taking help of the mean, you can calculate the standard deviation also. So it is showing column wise. This 1.26915, this value shows the mean of the first column only. Similarly, this is the mean of the second column only. So third column only, like that. Suppose you have some missing data in the suppose NOx. Here you have suppose the missing data. So what we will do, after calculating the mean, standard deviation, all these things here, you can fill the missing data with the mean, because you know the mean value, that is 1.101175 for this column only. That is why you can fill this value wherever it is missed. Similarly, you can go to last column also. You can see up to last column all the values are filled here. Similarly, price also indicates all the mean, standard deviation. Now coming to this mean, this is the minimum value of this particular column, and it shows the maximum value of this particular column. Now in between there are some percentiles like 25 percentile, 50 percentile, 75 percentile. What does that mean? That means like 0.049 this much is this threshold for 25 percentile, and 25 percentile of the data are below this value. Similarly, this is the threshold for this column, 50 percentile of data below this value. Similarly, 75 percentage of data below this value. Now, we are trying to plotting the data. So we plot the data here with the help of this code. Like we use SNS, C1 library here. Now you can see visualize the data set, how the data set is distributed. From here you can get information like particularly on which value the data set is more, the data values are more repeated. Similarly, you can see here in between 20 to 30 somewhere, this is the highest value, and somewhere in after 40, 41 somewhere, there is no value in the data set. Like that, some Gaussian kind of distribution we can visualize by using C1 library. Now coming to correlation part. So why do we need to go through this correlation matrix? Because it shows, it gives us an idea about how the data points are related to each other. That means there is a matrix here which has all the features in the rows and all the features in the columns. Now we can see here the diagonal first, which indicates 1. That means obviously this a feature, suppose crime is the feature. So crime, how it is related with crime itself? That means it is fully related. That's why it is showing 1. Similarly, second one, Zn, how Zn is related with Zn? It's fully related. That's why it is showing 1. So that's why 1 indicates this itself, how it is related. So there is no particular use of this one, but we can see like how crime is related with Zn, how crime is related with INDUS, like other parameters here, features here. So we can see in the right side, you can see here, that is annotation here in given right side true. That meaning it shows the color with that, how we can observe this one. You can see the light color indicates towards 1, and the dark color converges towards minus 0.75. So how much it is dark? That means that value is divergence towards negative. How much it is light, that means the value is divergent towards positive. From there we can find whether it is highly correlated or lightly correlated, like that. So there are two types of correlation we can find here, that positive correlation, negative correlation. So positive correlation means, suppose one data point value is increases, then the other data point value also will increase. That is positive correlation. And negative correlation, if one data point value decreases, the other data point value also will decrease. So we can find which data point is positively correlated with which data point, which data point is negatively correlated with which data point. So for data analytics and visualization, this is the best one preferred by the researchers usually. Now again, this same step we are in dividing the data set into two parts, training and testing, and further we are subdividing the training part into two. First part contains all the feature and second part contains the target column. Similarly, testing again divided into two. The first part contains all the features and second part contains all the the target column, sorry. Now you can see here, previously there were 14 features, right? Now what we did is, out of 14, the last column was price. If you remember, the last column was price. That means we are predicting the price. That is our target column. That is why what we'll do in X-train, what we'll do, the price column will drop that one. That means all the 13 features will belong to the X-train, but not the price column. Similarly, the price column will separate into Y train. Similarly, X train also, Y train, X test also, Y test also. So as usually there are 4 parts here, and each part shape is shown. You can see same 0 to 505 rows are there. There is no missing data here while doing the pre-processing. But the data set, now it's divided into 13 column one part and the target column another part here. So again, it can be seen like test data size is 0.2. That meaning is we are splitting our data set into 80% of training and 20% of testing. So in previously I've shown like 70% of training with 30% of testing. Now in this case I'm showing with 80% of training and 20% of testing. Now random state indicates like how randomly the data will be chosen into training and testing. If we don't give random state, what will happen? The sequential it will choose. But we don't want to improve the efficiency, accuracy of the data set. We would do with some complexity, like randomly it will choose the data set. So here there are 13 features. That one training. Here it is X train, then X test, Y train, Y test. Now we are implementing here linear regression model. As it was discussed already, like there are many regression models are there, like linear regression model, logistic regression model, polynomial, and each regression model has different purpose to use. So for simplicity purpose, to better understanding purpose, I have used here linear regression model. So why it is called linear regression means there is a linear relationship between the dependent and independent data. That is why in that case only we can use the linear regression model. So what is the dependent and independent data? That means what we are predicting is dependent, and what features we are using is independent, because that dependent data, by taking the features only it can predict. So this linear regression model again directly we can import from the sklearn library. It can be seen here. The libraries are already imported here. Now the model is fitting already. The model is fit here with the X train and Y train, and regression linear regression is applied. Now the work of KNN is to give the prediction. It can be seen like generally what we do is we measure the accuracy in classification, and we find the error rate in regression. So what error rate we found here? We used the RMSE, root mean square error. There are so many other techniques also there, but for simplicity again I have used root mean square error. Root mean square error means we will find the error with whatever the technique means. First we will find the error. Error means actual value and difference between actual value and the predicted value. and we'll put it the square. We'll calculate the mean and overall root of that one. That is the root mean square error. So what we get root mean square error is 5.43. That is not supposed to be a good error. But why it may happen means because the data set might have some biased value towards like suppose the data set have missing value and suppose it is filled with the same values only, mean value. That means the mean value will be very high. So in that way, the data set may be biased toward that. So the rate will be maybe increased again. So if the data set is a good, otherwise before implementing with the machine learning approach, if you pre-process the data set very well, then the error accuracy will be very good. I mean, that means we are expecting that our error should be minimized towards zero only. It's not going against the zero. So here 5.43 is not that much a good accuracy, but if you pre-process the data set, we may get the good accuracy like 0.9 and something like that. Okay. So this was the training error. Now the testing error also we got somewhere like 5.38 something. So after applying the pre-processing technique, we may get a good result also. Now with this, I like explained the KNN implementation with two different data sets like Iris and Boston. So Iris was for classification, Boston was for regression. So it's not like this is the only knowledge within we can experiment everything. So if we search more about this, how KNN, variations of KNN can be implemented, how the same KNN can be implemented in for different data sets also, then we can come across some new problems and new different solutions. Yeah. Yeah. Okay. So I would like to thank you for this opportunity to share my knowledge and get this presentation. So now I would like to take this session over to Dr. Arijit. Yeah, thank you, sir.
So thank you, Dr. Arijit, and thank you, Mr. Ramakrishna, for sparing your time and for discussing various issues on machine learning as well as IoT in this 1 week FDP. So that was a very knowledgeable lecture, and there were a number of queries the participants have raised. So once again, Dr. Arjit, I'm very thankful to you. You have spared time and share the information knowledge with the participants of this FDP.
Okay, thank you. Thank you for your invitation and giving me this opportunity to interact with different participants. And I hope we'll meet in some other occasions with all the participants and all the organization along with you. Okay, so to all the participants, please feel free to contact me if you need any sort of, if I can be helpful for you in anything. Okay, so thanks again, all of you, for listening my talk.
Thank you so much, sir. Thank you so much. So, dear participants, now our next session is at 2 p.m. So, we'll meet at 2 p.m. I will share the details in the WhatsApp group. Thank you so much for listening.